All right, so this is a review from week 23, I believe, or week 22. It's week 22, coming back from winter break. It's the first week of February, and for geometry students, we learned about parallelograms. We did a Desmos. We also have an edulastic that's in the gradebook already, so if you haven't done it, do it. And then we took these notes. So a parallelogram is a quadrilateral, meaning it has 4 sides, with both pairs of opposite sides that are parallel. So remember, this symbol means parallel. So a quadrilateral has 4 sides, but a parallelogram, by definition, has opposite sides that are parallel. These are other characteristics of parallelograms. Sorry, there's like check marks everywhere and stars because I've been writing on the same e-glass all week. So here's important characteristics of a parallelogram, which you geometry students need to write down, because we're going to build on these facts for rectangles, square, rhombus, etc., which are in the Desmos for the week. That's like 35 slides. So anyway, so parallelograms have 2 sets of parallel lines. We already know that. These sides are parallel to each other, and then their opposites are parallel to each other. Okay? Now I'm going to just label it like A, B, C, D. And then we also know that 2 sets of congruent sides. So parallelograms have 2 sets of congruent sides. So that means that this side is congruent to this side, and this side is congruent to this side. Hopefully you follow that so far. Parallelograms also have opposite angles that are congruent. So that means that this angle, angle D, is congruent to its opposite angle, which is B. So if you found out that D was 80 degrees, then that means B is 80 degrees. And then same for A and same for C. So opposite angles are congruent. Then we have consecutive angles are supplementary. Consecutive means next to. So consecutive angles are supplementary means that any 2 angles that are next to each other in a parallelogram have to add to equal 180 degrees. That's what supplementary means. So if B is 80, what does C have to be? 100, because 100 plus 80 is 180. And if C is 100, you know A is 100, because they're opposite angles. Or you could just think D is next to A, 80 plus 100 is 180. So A has to be 100. And then if you notice, if you add all of the sides, you have 100 plus 100 plus 80 plus 80. That equals 360 degrees. Any 4-sided shape in geometry, in math in general, has a value, the sum of the internal angles is 360. And I'll get back to that at the end. Diagonals bisect each other inside parallelograms. What that means is that the diagonals cut each other perfectly in half. So I'm going to draw another parallelogram because this one's all crowded already. So A, B, C, D. So a diagonal is when you connect opposite vertices. So that's my diagonal. That's another diagonal. Diagonals bisect each other means that they cut each other in half. Okay? So let's say that the intersection of the diagonals, we're going to call it point M. Let's say AM is 5. Then that means that CM also has to be 5, because this is the intersection of the diagonals. It's like the bisection of them. And then let's say that DM is 7, then that means BM is also 7. So how do we know that that this quadrilateral is a parallelogram? We would say because the diagonals bisect each other, just by looking at this picture. Now the last step says diagonals form 2 congruent triangles. If you need to write this down, pause the video because I'm about to erase it. So when we talk about diagonals forming 2 triangles, 2 congruent triangles, it actually has to do with triangle congruence. You can prove it many ways, but I'm just going to use triangle congruence. So let's say I have my parallelogram, and I have A, B, C, D, and I'm going to connect the diagonal. How many triangles do you see? 2, right? So the last characteristic of a parallelogram states that diagonals form 2 congruent triangles. So I'm telling you that these 2 triangles are congruent. Now I'm going to somewhat informally prove it to you. So we know that this diagonal is equal to itself by reflexive property, right? So DB is congruent to itself by the reflexive property because it's the same, obviously same segment. Then we also know that this side is congruent to this side, because if this is a parallelogram, this side is equal to this side, and then this side is equal to this side, because opposite sides are congruent. So we essentially proved that by side, 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 this triangle is congruent to this triangle. So if that's the case, then that means that this parallelogram is indeed a parallelogram and that it has two triangles that are congruent to itself. And remember, corresponding parts of congruent triangles are congruent. So we could then say this is equal to this. This is alternate interior angle with this. This angle is alternate interior angle with this angle. They correspond to each other, and corresponding parts of congruent triangles are congruent. Okay. Sorry I talked really fast. I just needed to make this video somewhat short. Make sure you do your edulastic. Thanks, guys.